So a recap, what did we end up doing? We had the simple date calculator method. We made it easier to read. We made it easier to understand. And we did it with some pretty simple refactorings. We found a bug. You could argue that if we had chosen different test cases, maybe we would and maybe we wouldn't have found that bug. But because it forced us to think about boundary value testing, that's one of the places where bugs tend to creep in. And indeed, because we had to write a test case for a boundary value, that's ultimately how we found it. And an observation that you should get from this is to the extent that the helper methods are isolating individual tasks done by the main method, you could argue that if we had developed this using TDD, it would have gone a lot more smoothly, because part of TDD involves thinking about how you're going to use those helper methods. If you write them in a way that they're externally testable, presumably that means that you're writing them in a way that they're going to be easily usable by the higher level methods. So again, you're already putting to use all the skills you need in TDD, just put them into a different order. As Dave showed when he first talked about the SOFA guidelines and the idea that metrics are one way to judge the quality of your code, indeed, the before versus after of this, even on this simple method, we were able to improve our FLOG and REEK scores. So recall that the FLOG score measures complexity. REEK is a tool that tells you about design smells and code smells. So we were able to do that as well. And the refactorings we used are just a couple in a much larger catalog of refactorings. I've said that we like the Fowler catalog. It's probably considered definitive by most people. But what did we use? Well, I've highlighted in red the refactorings that we use. We decomposed a conditional. Does that mean that the conditional died and is putrefying and rotting away? No, it means that we took each branch of the conditional and essentially pulled all the logic of the branch out into a helper method. And one of the reasons to do that is it makes it easier to say if something, then something. Well, you know right away what the if is trying to do, right? As opposed to if something, 28 lines of code, else 28 other lines of code. That's much harder for a human being to parse. Other things that are sort of in a similar category, replacing loops with collection methods. If you're coming into Ruby from other languages that are imperative, languages where you write for loops, we already know that in Ruby there's collection methods, there's iterators, there's all these other ways to deal with iteration that are not sort of straight for loops. Another neat Ruby-ish trick that doesn't apply in a lot of other languages is extracting enclosing methods with yield. So we already know that if you've got a method that is called from several different places, it makes sense to pull that method out. That's a way of drying out those uses. But you can go further in Ruby, which is if you have a chunk of before and after code that are used in different places, you can capture that whole thing in a single method that yields to the thing you want to do. And we showed an example back when we talked about an introduction to Ruby using the yield feature. One of the uses of this you see a lot in Ruby is with file I/O. So a very common pattern is open a file, do some operations on the file, and hope you don't get an exception, and then close the file. So Ruby factors out the open and close parts and yields to the middle part. So this is a trick that you can do in Ruby that other languages don't support terribly well. And I'm not going to go through the rest of these refactorings and smells in lecture. There's a good deal of detail about it in the book. And of course, the ultimate reference is really to go to Fowler, which has very detailed examples. And if you buy the language-specific version, which I recommend, the examples are Rubyistic. They're idiomatic Ruby. So it's also a good way to get a sense of what good code looks like in Ruby, because he gives you the before and the after. What does it look like before the refactoring? What are the specific steps? What does it look like after the refactoring? And as we saw in this case, we addressed the SOFA guideline of sticking to a single level of abstraction. We did it in this case by extracting methods. We're going to see when we start talking about design patterns and about object-oriented design generally that there's an analogous thing you can do, which is extracting entire classes, where you're basically passing a bunch of parameters around to different methods. And what you come to realize is that those parameters really, because they travel sort of in a herd, that means that there's some class waiting to be extracted, that those parameters collectively describe some kind of object. And if you gave that object its own class, you wouldn't be passing clumps of parameters around anymore. So again, as we've said, you get more practice doing this just by doing it. The first few times you do it, you can sort of use the examples that we've done kind of as a cookbook, but you'll very quickly get used to seeing when something just doesn't look quite right about your code. And that's when the refactoring catalog comes in handy. So let's wrap up our understanding of the simple refactoring example with the following question, which is, which of these four is not a goal of method-level refactoring? And so far, all we've really done is method-level refactoring. We're going to be talking about class-level refactoring, where you can create or destroy classes to make your code better. But just with regard to method-level refactoring, which is not a goal, reducing the complexity of the code, eliminating potential code smells, eliminating bugs in the code, or improving the testability of the code. So one of these four is not a primary goal of method-level refactoring.